Right. Well, the tradition, I guess, on the podcast is to always start off just asking about coffee habits, or if you don't like coffee, if there's a different stimulating beverage or non-stimulating beverage that you feel any affinity towards.
Well, I do love coffee, but I'm a bit snobby and picky about it.
Okay.
And when I have good coffee that I like, I'll try to get it nice and fresh, freshly roasted, more or less, which is kind of tough
Mm.
sometimes. I don't really have like a roasting place around here that I frequent. And then I use the AeroPress. However, a couple months ago, I just decided I was tired of being disappointed by my coffee, and I just started taking caffeine pills.
Oh,
So
dang.
yeah,
Um,
that's
yeah, I feel like those caffeine pills are something I've never wanted to explore because there's no culinary side to it. But like at the same time, who cares?
right. I mean, it does sound like unhealthy or weird or something, but you pop a pill, it's the exact same amount of
Yeah,
caffeine, and
it's quantified.
it's quantified. I can take one and just hop on my bike and get out of the house.
Nice.
So there's no cleanup or anything.
Do you do like the like no dose or something, or is it the I think that's like a brand, or is it like smart caffeine, like the theanine and caffeine?
Nah, it's just
Okay,
you know,
just anhydrous.
it's just caffeine.
Beautiful.
I have had caffeine with like some kind of B vitamin or something in it, but
Hmm.
it
Cool. Well,
seems to get the job done.
what is tasty coffee to you, or like what how in what way are you snobby about it?
Just when it's.
I support your snobbery.
I mean, back when I lived in California, I used to just go to Pete's, uh, grind it there sometimes, put my face to the bag and feel the shiver down my spine.
Hmm.
Um, I like, I remember liking Garuda a lot, sort of, um, I don't know, South Asian, darker, earthy, something
Hmm.
earthy.
Nice.
Good point. I have roasted my own coffee several times and enjoyed that. That's just a fun little project. You can do it with a popcorn popper, like an air popper.
Nice. Cool.
It kind of takes a while because you have to do like a quarter ounce at a or some small amount for
Hmm.
each little batch. But it's a fun thing to do. And I also got a better idea of how it evolves after you roast it, because it doesn't
Hmm.
smell or taste great or anything right after you roast it, but within that like 24-hour time frame, it really starts to come to life.
Yeah. This guy, Scott Rao, who is like my favorite coffee head, he has a very, very specific sort of like data-driven way of roasting coffee that you might want to like read about on his blog and stuff, where it's like, you want to have these different curves align with
Oh
like rate
yeah.
of rise and yeah. Anyway, well, now that I know who you are in terms of coffee, I suppose we can talk about real things. So I guess the way I was thinking about the conversation going is like, uh, sort of through your career of education, like starting with guitar stuff in CalArts, moving to math, and sort of like applied math in music, and then what you're currently doing in neuroscience. Sound cool to you?
Sure. I can just give a quick biographical sketch, I suppose,
Yeah.
which is that I grew up mostly in Southern California and got really into guitar in high school. And I went and saw Miroslav Tadic play a solo concert at Loyola Marymount once, and I was just so blown away. I was like, I gotta go study with this guy. He's just incredible. He improvised 80% of that show, and I was just so blown away. And so I set my sights on that and ended up going. That's where, so I did my BFA there, starting in I think 2003, and 2004. That's where I met our mutual friend Mike Kudirka when he was um, working on his master's, and we hit it off. We were roommates for a while. He taught me a lot about classical guitar. I
Hmm.
had really been more of a jazz focused player, but one of the great things about CalArts is that I could just study anything. I studied North Indian classical music quite a lot my first year. Started getting into more avant-garde jazz and also classical, especially contemporary classical composition, and was writing for classical guitar. And also, when I was living with Mike, I was taking a music history class and finding it kind of dull. And he really he really brought some life to it. And we ended up renting a couple of gamba, viola da gamba from the school, and we would just open my music history textbook to some random medieval thing and sight read it badly, I'm sure, because I don't know how to bow an instrument. But it really captured me. Played continuo in an opera and really enjoyed that, because that was kind of like being in jazz. You've got this figured bass thing and you're just kind of improvising over the changes, more or less. And I also really like accompanying singers. Okay, and then sort of near the end of that period, I started getting more into just quote unquote regular. By the way, quote unquote, that's weird, right? Like you would say quote regular, unquote. It's always bothered me a little bit, but you know what I mean.
Yeah.
So I ended up getting into more songwriting. I got obsessed with Brian Wilson and Pet Sounds and other various songwriters that are brilliant, like Townes Van Sant and Joni Mitchell, all kinds of stuff. And sort of put my mind to thinking about that stuff a lot more. Both just individual songs, but I had charted out my favorite albums in terms of tempi and keys, and really kind of getting into the weeds of how does an album work as a whole and things like that. And so for a few years, I was just your typical starving artist, bouncing around, teaching middle schoolers Here Comes the Sun and Smoke on the Water, depending on their motivation level. And I enjoyed that, and I like teaching, especially, exclusively when they're interested and motivated. Otherwise, I'm just not really that interested in trying to say, did you practice?
Yeah.
I would just talk to them about other stuff, because they're kids. They just want to talk and just discover the world. And I still teach, but I'm teaching undergraduates in neuroscience now, and actually just did a 6-week teaching thing with high school students, which I really enjoyed as well. Just really enthusiastic. Anyway, so I went home to visit my parents in northern Michigan one winter, and I was just like, God, this is gorgeous. Just quiet, snow. And I was just kind of getting fed up with Los Angeles a little bit, sitting in traffic. It was hot. Lived out of my van for a while, which was a fun little adventure. But I was ready to be done and figure out something else to do. Whether or not it was music, I just was ready for a new chapter. So I moved to northern Michigan, outside of Traverse City. By a weird coincidence, Mike Kudirka also ended up there teaching at Interlochen, which is, we just seemed to be crossing paths. And I was kind of trying to scrounge up some lessons here and there and just see what I could do, but mostly I was just thinking about how I didn't want to be teaching Smoke on the Water when I was 50.
Right.
And so I just like, I've always loved lots of things, and I've been really into the outdoors, and I thought, maybe I can find some kind of outdoorsy, biology-centric kind of job. So I started going to community college up there, intending to do biology. And biologists have to take calculus. And so I taught myself enough to test into the calculus courses. And once I was there, I just got the bug and thought, this is so cool. This is and physics too. And so when I ended up transferring to University of Michigan to finish up, I wasn't sure if I was going to do biology or math. I took a genetics class and a linear algebra class. The genetics class it wasn't clicking for me. Like, knowledge was going in one ear and out the other. As fascinating as I found it, the experience was more stressful than I had hoped.
Mm-hmm.
On the other hand, my linear algebra class, which was like a theoretical linear algebra class, they use it to sort of test you out to see if you want to be a math major, because it's all about proofs and logic. And I just realized this is what I like spending my time doing. And I'm probably going to be doing a lot of homework and study. So I just went that way. Fortunately, there was a mathematical biology sub-concentration, so I did that. And while I was there, I've always been interested in the brain and research. So I got a couple of research mentors, and one of them's a mathematician, one's a physicist, Victoria Booth and Michal Zochowski. Shout out. I'm sure they'll hear this. And I learned how to code. I was simulating populations of neurons just to see, how they synchronize, how they desynchronize, and all that kind of stuff. And had a great experience, and ultimately decided to go to grad school. So I applied to Boston University, which is where I am now, I'm about to go into my 6th year for a PhD in neuroscience, technically computational neuroscience, but that's sort of a sub concentration.
Nice.
And now that I came in with all this math and computer chops, and now I'm working with mice all the time, which is also something I didn't expect to see myself doing, becoming an experimentalist.
Would you rather work with Mike or mice?
Mike. 100%.
Cool. So when you were talking about the going through albums and like figuring out the like times and durations and everything, that's something that is all too familiar with me. Like I went through this big Janet Jackson phase once, and I was going through her stuff and analyzing it down to the millisecond, and then trying to abstract out whatever I could, and then just replace it with my very much not Janet Jackson stuff. So I'm glad to know that you are like considering things like how they work as a whole. Did you like get any sort of insight or end up with any like sense of like what the ingredients are for like an elegant album? Like how long is the perfect album, or how many songs? Like,
well, they all follow the golden ratio perfectly. I don't know that I found a unifying theory.
Mm-hmm.
I mostly just wanted to. I think it did inform me. I did make an album myself, and friends played on it, and it was just a really great experience for me. And I think what I kind of took from it took from studying albums, is going to sound kind of trite or obvious, but just trying to balance having it be a unified whole, but at the same time not uniform.
Mm-hmm.
Songs have their own individual character, their own arrangements, their own tempi and keys.
Mm-hmm.
So when I was putting together my own music, I was pretty conscious of trying to find that balance and make it sort of a complete story, beginning to end, more or less.
Yeah, I feel like just having a beginning and middle and end is like, that's already like enough of a challenge, but to make it have any sort of elegance beyond that or whatever, like that's
for sure. And I also really enjoy when you get into an album, and I'm an album guy.
Mm-hmm.
And you think about the Beatles, and especially their later albums, you hear lines, quotes, ideas that kind of resurface, and you're kind of piecing it together. You feel like you're reading a book, because ideas and themes keep resurfacing, And I know some of that's intentional, and some of that's also just when you're writing a bunch of songs, there's only so many things that you're thinking about and trying to express. And so you're gonna themes are just gonna naturally
Hmm.
start surfacing in different places. But those are other things like little leitmotifs that might appear here and there.
Hmm.
I'm a huge counterpoint fan, so I love just inserting little things that probably nobody will ever know. But when I listen to it, I'm like, yeah, that was this other theme, but I ran it backwards and whatever.
Hmm.
Or this one's stretched out in time by two, and kind of geeky
Totally, like little
stuff like
canonical
that.
things.
Sure, yeah. And I don't know if it penetrates or not, but I enjoy it,
Hmm.
and it's really I made it for myself. So,
Nice.
um, and
Who?
I'm starting to get back into playing more, but it's a little difficult for me to be really creative in a way that satisfies me without doing it all the time.
Totally, yeah.
Because if I just do it an hour here and there, I'm kind of just going to repeat the grooves in my brain. I'm just going to be moving down the grooves in my brain. I'm not breaking it, and I don't really want to do that. I, I'm like looking for some new like just some comedy electronica or something, like whatever it is, just something new and fun and different is what I like to do and not repeat myself.
I feel like the last time we talked, I think you broke the seal by saying orthogonal, and that's on my like bingo card,
Uh-huh. Uh-huh.
uh, like catchy words to say. But I guess like yeah, like my current thing is to try to always disrupt where I'm going and like do entirely novel stuff as often as possible. But that's like a huge chore
Yeah,
to
for sure.
maintain.
I mean, it's also such a pleasure if you're
True,
just the
yeah.
kind of person that loves to explore. I mean, there's nothing better. At the same time, you're always confronted with the fact that you suck at something.
Hmm.
But
Absolutely.
I enjoy sucking at stuff. It's like being a kid again. Kids
Hmm.
suck at everything, and they don't mind because they're just used to it. And I think as adults, we once you start having competency in some area, you start to feel like that should be the norm for everything, and you get frustrated and quit. But I enjoy learning new things and stinking at them, and
Hmm.
yeah. So, and that's always been sort of my strength and weakness, probably because as I'm a jack of all trades,
Mm. A generalist, we say.
a generalist. That's good.
Do you have
Put
any
that in my.
favorite? Do you have any favorite guitarists or like composers besides the ones that you've mentioned? Like any that you sort of like, desert island guitarist?
Ooh.
I'm trying to figure out where like Venn diagram overlaps in terms of guitar interests.
Yeah, honestly,
I mean, I know Miroslav, and we talked about Dushan briefly.
yeah, I'm a big fan of Nels Klein,
Okay, nice.
and um,
Check the other weirdos like Henry Kaiser or like sort of like these more like Derek Bailey.
yeah, yeah. I I feel like I kind of started gravitating away from guitarists
Hmm.
in general, which I think is pretty common for a lot of people. Like,
Totally.
especially when you're into jazz, you start out and you're seeking out all your jazz heroes on your instrument, and then you're like John Coltrane, amazing.
Yep.
You just so I feel like yeah, these are people that I love, guitarists, but I don't really have a North Star or
Yeah.
several of them probably anymore. It's
Yeah, I mean,
um,
if you say train as your answer, that's fine by me.
okay.
That can override it because I mean,
Wes
like,
Montgomery. There we go.
yeah,
I
yeah,
got one.
yeah. I feel like guitarists love to be obsessed with their instrument in particular, and I've always sort of thought that it was a dumb instrument, which Mike and I talked a lot about just like the tuning and stuff. So, I mean, I guess we should get into that sort of. So the guitarist tuning has always pissed me off, and so it sounds like you and Mike are attacking this problem with your replaceable fretboards, like the magnetized fretboards at MicroTone. So, what exactly have you been like up to in your work there, And like, what does a day of MicroTone stuff look like for you?
Oh, well, so just I guess a brief primer is that, as you mentioned, we've got this MicroTone guitars venture, and we have thus far classical guitars and steel string guitars, and are working on electrics to essentially have a magnetized fretboard, and you can slide on and off, or sorry, magnetized neck, and you can slide on and off different fretboards to work in different tuning systems, or no tuning system if you want to play fretless or something.
Mhm.
And this is a project that Mike, since Mike is an expert in tuning theory, had always been interested in, and since we're both interested in early music, especially, and modern tuning system is a modern invention, and it's really cool to go back and just think about.
Mhm.
I love thinking about things that seem like received, like they've always existed, and then you go back and find out that's one of my favorite feelings. So that's equal temperament, and we just started working together when he was at Interlochen, I think mostly, and I was just starting to learn math and coding. And he said, well, he had been making these 3D designs to print fretboards, just kind of rudimentary in that 3D printing technology is like, you know, it's a piece of plastic.
Mhm.
It's cool, it's awesome. But he had also been, there's just so many, there are several free parameters when you're designing a fretboard, just in terms of the guitar you're using, the tuning system, and so on. And it can be quite annoying to have to sit there and compute where the fret goes for all these things.
Mhm.
So he's like, hey, do you want to try to, I don't know, see if you can do this in code? And I said, yeah, absolutely. I'm always down for some kind of side project.
Mhm.
And we kind of just bounced that sort of stuff back and forth for a couple of years until I got a little more serious. And now it's much more sophisticated operation. But my central role has pretty much always been just creating code that spits out designs that the CNC machine can read.
Mhm.
Mike will say, here's the parameters, here's the tuning system. My code will read that in, create the design, send it out. More recently, I built we're working on a tuning app so that users can just dial up on their phone, so that they can pull up the app on their phone, and it's got your fretboards that you own, and so you can tune your open strings and all that. So that's something that I had a lot of fun doing, just learning new algorithms to do this and sort of tweaking them and trying to optimize them for our particular purposes. So, in short, I feel like most of the CNC stuff is pretty much where it needs to be. I don't know that I'm going to be doing too much work on that aspect, at least in the short term. And there are little tweaks. So I guess the day in the life would be like Mike pestering me for way too long because I'll like get busy and say, "Oh, I'll get to it. I'll get to it," and then it'll be for some little feature like, "Oh, can I? I want to be able to use this specification. Can you alter your code a little bit?" So for me, it's usually just relatively minor revisions on the code that I've written and push it, and he'll pull it, and so that's pretty typical. Getting this tuning app going is something my brother's actually helping out with, and he is more of like a user interface kind of guy, and I'm more of like a algorithms kind of guy.
Gotcha.
And I don't really have the patience or aesthetic whatever to design something that's beautiful and whatever. I'm just more,
Mhm.
I don't know, in another realm, I suppose. Um, another domain, I should say.
For these fretboard algorithms, can you walk me through a little bit of what that would look like? Because I mean, like, I understand a little bit about, like, like the logarithmic scale and, like, the ratio being proportional between pitches and all that. I'm not sure. Like, I'm curious how something would happen, differently with different tuning systems. Like, what would change about the code? And yeah, I mean, how do you figure out that placement? If there's a
So
easy to digest way to say it.
sure, a scale can just be defined as essentially the fraction. Each note in a scale degree, can be defined as a fraction between octaves. So we say, just by convention, there's 1,200 cents in an octave, CENTS, and you might in equal temperament, you would say 0 cents is your starting pitch, then 100 cents, 200 cents, and so on. That's how you get your 12 pitches. If you have some other tuning system, quarter common mean tone or whatever, you just define those steps as different cent values. Okay, so now you've got a different fraction of your way up the octave.
Mm-hmm.
And so if you think about the length of a string from the from the nut to the bridge, you just have to map those cent values. Cent values kind of exist on it's a linearization of the way we think of frequency.
Okay.
Because octaves double
Mm-hmm.
in frequency every time, and when you think of cents, it just sort of flattens that out for you. And then you have to sort of do the inverse on a fretboard, where halfway up between the nut and the bridge, that's 1 octave. Halve that again, so you're now 3/4 of the way up. That's 2 octaves. So you just basically have to map these cent values onto locations along this line. It's a fairly simple just transformation. Once you get it down, it's there, and you just run the code.
When you have figured out where to put all the frets and you put them down, if you just do it according to whatever placement you've mapped it to, is there a bunch of fine tuning, no pun intended, beyond that to tighten it up? You'll be like, this is the correct thing, but it has to be scooched over a tad.
Sometimes there's a tiny bit of scooching in order to. So let's say you've got a fret that's going to extend across multiple strings, or it ought to.
Mm-hmm.
There's no sense in making a fret that just goes over one string, and then you have another fret right next to it that's 1,000th of a millimeter,
right? Yeah.
Up 4. So you might as well just take the average of those two lengths and extend the fret all the way across, and there's no harm there. So there are tolerances. I'm willing to move these frets, take the average length or whatever, insofar as it doesn't alter the target pitch from beyond a few cents or whatever it is. I don't remember the exact parameter there. So yeah, there's stuff like that.
Gotcha. These tuning systems, I think, are largely it sounds like there are a bunch of historical ones, and I'm curious if you've ever done anything 13 tone equal temperament or something like that, or just some ugly prime number.
There's no such thing as an ugly prime number.
Well, yeah, I'm just.
Mostly I just work with the fretboards that Mike gave me for Christmas. And I don't have any really bizarre ones. If I were in Michigan where they're building these things, I think I would, screw around with some more exotic, weird things. But right now, since we're really trying to hammer down the core tuning systems that we think are going to be most useful to people, I think I pretty much just sort of play on those.
You're being sensible and practical.
That's right. That's right. A rare instance.
So to talk a little bit about math, I agree there are no ugly prime numbers, but I guess would that work at all the same way? The way that there's the harmonics, the harmonic series and all that. If you had a very odd, 23 tone equal temperament, that would screw a lot of stuff up, right?
Well, we could chart this out and find how far each of these intervals is from being in the harmonic series, and say, oh, this is likely to be more dissonant. And that's where an interesting sort of psychoacoustical component comes in, how complex the rational approximation or something would be to Maybe not rational. You could do some really weird stuff probably with fully irrational. Oh, in steps of E. Now I'm thinking about it. This is my E report. That'd have to be E multiplied by something. It's 2.7 cents or whatever. Right? What is E? 2.16? 2.7? I can't remember.
That's Euler's
I
number?
read a whole book on it. Yeah. It's a beautiful number.
I've been told over drinks by another very enthusiastic person that understands physics and all. So,
yeah, it's got some really cool properties. It also kind of blew my mind to think about. The further you go in math, the more abstract the idea of. It's almost like less thinking about numbers and more thinking about objects.
Okay.
In a way, like, how do you think of a number that has an infinite number of decimal? It just never repeats. These decimal places go on forever. I mean, 1/3. That's not a hard thing to wrap your mind around. But something that might be expressed as an infinite series, 1/2 plus 1/3. But I don't know. I don't have these series memorized, but yeah, you just start to think about quantities, or I guess as more abstract mathematical objects. And I think when I started getting into things like E and pi, you start to see them. There's just so many different angles that you can look at them from. And that's part of the fun. I love this process of recontextualizing something that seems like you understand it. But there's always ways that you can revisit it. It seems like, so I read this cool, I don't know, 5-page thing by a mathematician about the derivative in calculus, and he lists like 20-something distinct ways to look at it or to interpret it. And he talks about how the process of being a professional mathematician is always rediscovering new things about things you've known about for a long time. And that's really exciting to me. I've always really enjoyed that. And I think a lot of people might be a little bit put off when they see calculus for the first time, or any kind of more complicated math thing. But you should never think that you're going to just get it the first time you see it. It's going to be a lifelong journey of revisiting these things, seeing new things about it. I love that about math.
I really, I mean, like last time we talked, I feel like you admonished me for calling myself garbage at math. And like, when it comes down to it, I do spend an awful lot of time like recreationally on my calculator app, even just like doing like sort of tedious arithmetic. But yeah, I guess I'm curious about like how you would suggest a musician like find their way into math, if it's going to be like a huge process of learning. Like, you know, I've been trying to learn calculus for a while, and I need like a way to get into it and actually like, you know, get some friction and continue with momentum.
Yeah, I think it's maybe a little tricky because I think everybody's a little bit different.
Right.
I've always been fairly decent at teaching myself out of books, which is how I kind of got back into math, just textbooks. But I understand I'm also shit at lectures. I don't like lectures, almost never. I kind of just stopped going to classes after a while. Just like I'll drift out and I'll come back and I'll miss something. It's just too hard to stay in sync sometimes with lectures. So everybody's got to kind of find their own way. But I think the fact that you like it and are exploring it just goes a long way. I would just say probably don't overburden yourself with learning every last detail. There's so many details in calculus that I don't remember. And you're not going to, unless you're a math PhD and you're going to be grilled on this stuff for a qualifying exam or something. And there's a lot of stuff that I covered and I learned how to compute things, but I still haven't gone back to really understand them. They're just okay. Here's another little rant: is that there's hundred. Okay, what did it take? Maybe 150 years or more after Newton and Leibniz invented calculus for there to be a rigorous way to express these ideas. It took so long, and yet we expect students to just sort of absorb it first time through. It's like these were brilliant people, and it took like Euler didn't even have the geometric concept of complex numbers that we have now, just because there was some Danish cartographer who was interested in arrows and how you might be able to multiply two arrows to come up with a third one. These things are not supposed to be just something that you pick up instantly. And I think we kind of do a disservice by neglecting to tell students that these are ideas that they were hard fought. And yeah, we've maybe come up with a good pedagogical way to express them and expose students to them. But anyhow, back from that tangent, I'll just say you could probably just find the areas that are interesting to you and just try to use them, try to apply them, just play with them, and don't worry about all the other little details that are in the book. And you might, like, once you get a handle on some aspect of it, then you might find that it's just much easier to grab onto some other thing. Or I get why that's cool or interesting or important. And I think I also approach it the same way I approach learning music. I remember I had a ear training teacher. We're just learning intervals or something, or chords, or trying to pick out I think it was like in my last year training class, you just mash his hands on a handful of random notes and be like, do you hear this minor six in here? And it might be like nested within all this other stuff. It's like, yeah, maybe, but I'm used to hearing it just like root minor six, root, and the idea was like, just try to hear each interval in as many contexts as you can. Just try to look at everything from as many angles as possible. And something about that, your brain will just start to kind of absorb it and recognize it in many different ways. I think in math or any of these other technical areas, it's not so dissimilar. If you just limit yourself to the handful of examples that you see, then you might not be able to, fully internalize it. You might be able to use it in that particular context, but it's a good idea to try to look at some problem or idea from as many angles as possible. That's my approach.
Yeah, when Mike was talking about the tuning app, he mentioned autocorrelation and how he admires how you handle the waveform or something like that. So I guess that's very much something that applies to me, is like managing waveforms, and like I sort of like have a little awareness of like Fourier stuff, but how do you handle the waveform that impresses him? Or
I didn't reinvent the wheel here. I just found a bunch of papers on tuning algorithms and just try to find the one that seems most appropriate to our uses. Autocorrelation is a fast, optimized method that doesn't require a particularly long sample, so it's more useful in real-time processing. There's some other algorithms, zero crossings, and so on, that be faster. I know there's some other companies out there that are working on that kind of thing for more like MIDI guitar, where you've got to have super fast recognition of pitches in order to not have any latency problems in real-time processing. But we don't really need that. We just need something that's like decently responsive while you're trying to tune your guitar. And let's see.
Would you
I
call
don't
it?
know if I can give a great like quick rundown of autocorrelation or something without pictures.
For
It's
sure.
just a hard thing to summon.
Is
But
it fair to say that it's part of machine learning? I was briefly looking it up, and it was like machine learning, autocorrelation, but it didn't seem like a machine learning thing when I first heard about it, I guess.
I'm no expert in machine learning, but I don't. I think it's more of a statistics.
Gotcha. Okay.
Uh, and it's not so dissimilar from stuff out of the Fourier world as well. This
Hmm.
idea of sliding different um, waveforms against each other, and just sort of in some way sort of comparing this waveform against some template. It's just the difference is that now the template is itself. That's why it's autocorrelation. A you're comparing a waveform with itself after some lag, some period of time. And so if you take some chunk of your wave, use that as your template, and sort of slide it along itself
Hmm.
at
Okay.
different delay. So each one is sort of a delay. Imagine like playing against a delayed signal of yourself.
Okay.
Um, if that waveform is periodic at say 100 hertz, then when you slide the waveform against along at a period that corresponds to 100 hertz, so you know, 1/100th of a second delayed, then they ought to look fairly similar.
Hmm.
That's the idea of periodicity in general. Is that if this thing repeats, if you have a sine wave and I slide the sine wave by one period, then it's going to look similar to itself.
Okay. Yeah.
And so that's basically what how autocorrelation works.
Hmm.
And what you do is you just slide these waveforms against each other or against itself, and at each lag, each amount of delay, you get a number for how similar it is to itself or the template. And the one that is most similar, you can just say, "Oh, that's probably the most significant period in here." And there's a lot of subtleties here and ways that you can optimize it for the guitar or plucked instruments. Um, there's stability problems sometimes where if something is periodic at 100 hertz, it's also periodic at 50 hertz.
Right. Okay.
Am I getting that right? I always have to
Or
do
double.
this in reverse. So it's easy to mistake the wrong octave, for example,
Gotcha. Yeah.
and there's some jumping around in the estimate that you try to smooth out so you're not accidentally saying, oh, this is a 50 hertz thing as opposed to a 100 hertz thing. Because when you jump down to the 50 hertz thing, the temporal or the resolution is different. And so your estimates are going to, even if you're just saying cents off, you would think, what difference does it make what octave I'm looking at? But there are some subtleties there. And when you're also, you can use other techniques to get sort of super resolution
Hmm.
through estimation.
Interesting. I feel like I sort of understand. Uh, I have a general feeling for what you're getting at here, I think. But yeah, maybe when I put this out, I'll put some pictures over it and or like put some, like graphs or whatever,
Sure.
figures.
Yeah, I
uh,
think there's actually some decent little animations on just the Wikipedia page for convolution and autocorrelation that demonstrate some of these things. So I guess here's my other recommendation for trying to learn math:
mhm.
is learn coding,
Gotcha. That
because
makes
there's
sense.
not
Yeah.
a whole lot that you need in order to just get plotting things that you wouldn't be able to do just by hand or whatever. And so there's a pretty limited and free set of tools and skills that you need to start just trying things, just exploring. It's kind of like your instrument
Hmm.
or a piano or something. you might be a composer or a theorist, but you're still going to need a piano there to just try stuff out and go, oh, cool, cool.
Yeah, just
And
different
so,
keyboard.
yeah, for me, it's different keyboard. So that's my recommendation.
Cool. That makes sense.
Yeah.
Let's see here. So, do you have a time limit, by the way? We're getting it up at an hour-ish, but don't want to,
Not really.
Cool. Well, I guess let's talk a little bit about the neuroscience stuff that you're doing. So, you're at Boston University, and I know that you're working with like optogenetics and stuff a little bit, or is that right?
A little bit. I kind of got a little overextended on projects that are pretty different and haven't done a lot with optogenetics since sort of refining my focus. So what I do is 2-photon calcium imaging in live animals, mice. So basically, this pond scum it was discovered, had this fluorescent molecule, and some very smart people figured out how to connect that to some other molecules so that when, for example, in the presence of calcium, this fluorescent molecule would become activated. When calcium is not there or in lower concentrations, it would unbind and then it would go back to its inactive state. So why that's important is because when a neuron fires, calcium rushes into the cell. And so when calcium rushes into the cell, it can bind to this molecule, and it is able to fluoresce. When I say able to fluoresce, I just mean you have to stimulate that molecule with some light. It's not going to just emit energy it doesn't have. You have to put some in, and if there's any fluorophores that are in the active state, they'll absorb that energy and then re-release it out, and you collect that light. So these neurons are genetically modified to express this protein in, say excitatory neurons, or you could do it with inhibitory neurons, or whatever it is that you're looking at.
And these are the opsons, or is that right?
Opsons. That would be more like optogenetics.
Gotcha. Okay.
So an opsin is something that's a slightly different technology where in response to light, it actually opens ion channels in the membrane that allow the ion channels in a membrane of a neuron open and close in some particular way that makes them fire. That's how they fire.
Okay.
And so what I'm looking at primarily, it's really just reporting firing, where instead of forcing it to happen. That's optogenetics. So if, for example, you could genetically tie channel rhodopsin to dopaminergic neurons, and then you run a fiber down into the dopaminergic area of the brain, whatever it is, PTA or something, and you're going to say, oh, I wonder if I can make this mouse prefer the left side of its environment over the right side just by stimulating its dopaminergic areas. That's like a channel rhodopsin optogenetics thing. It's gotcha. A manipulation rather than just of reporting.
Okay, gotcha.
Yeah, so there's all kinds of cool stuff in neurophotonics, which is basically just the application of light to studying the brain. It's actually pretty mind-boggling. Just the scope and the range, the amount of creativity that goes into to these tools, and that's what's so exciting about it. It's evolving so fast, and there are a lot of minds coming from different areas working on these problems. I'm just a user of that stuff. I don't develop it, but my primary interest is in the brain and not in the tools necessarily. But it's a fascinating area, and it's just always changing, and we're going to get cooler and cooler data. It's imaging deeper and deeper and faster, and it's very neat.
Nice. Um,
Oh, so I guess maybe just to finish up,
yeah.
the quick summary is that essentially you can just replace a bit of the skull with glass, so it's literally a window, and that's how you get the laser light into the brain that stimulates the fluorophores, and you can collect the light that comes out of it. And so, because the visual cortex is it's a pretty accessible area anatomically, that tends to be one of the more studied areas of the brain, as opposed to say auditory cortex, which is more difficult to access. It's more like on the side of the head rather than the back. Just depends on the shape of the brain or which species you're looking at.
Yeah, I guess I've like had, some sort of allegiance to the ears and like auditory processing just being a music guy, but it's interesting that you have gone from music to the visual system. And so I'm curious if there's any sort of way that you think that can be unified, or if, that's I might just be trying to go for some esoteric way to think about it, but like
Oh,
does
not at all. Yeah,
the
there is hopefully a beautiful unifying theory of the brain or of the cortex,
Mhm.
which is all that stuff on the outside. Cortex means bark in Greek, so like the bark of a tree. And especially in humans, there's been just this explosion of the amount of cortex we have, evolutionarily speaking. And unlike deeper brain areas, which have maybe had the time to evolve and specialize in all these particular ways, the cortex has all evolved so quickly that there's no way that each bit of cortex is going to, I shouldn't say there's no way, but it very much looks like evolution found some generic computational device and just duplicated it everywhere. Said,
Interesting.
well, if as long as I just plug in auditory inputs to this area, the Turing machine, the brain Turing machine will compute auditory stuff. If I plug in visual input, it will just do whatever it is that cortical circuits do. And so our lab really is, and I'm really interested in just what is this cortical computation that's occurring, possibly everywhere, with variations, of course. There's been enough evolutionary time for there to be variations on the theme to optimize for particular aspects of vision or hearing. But basic idea is like we're studying vision because we can pretty easily control what an animal sees,
Mm.
and we can pretty easily record what happens in response to it. So it's a good model system for studying the cortex in general. And so, and actually, a lot of the literature that I'm reading to inform what I'm doing does come out of the auditory system.
Mm.
There are these themes that just kind of keep popping up, and we're looking for clues as to what this um, generic uh, skeletal structure of computational or of cortical circuitry is, and
Mm.
how it gives rise to intelligence and behavior as we know it.
Interesting. I mean, do you have any insight that you can share on that sort of like computation?
Sure, I can try. Um, I don't want to mess this up.
What are some like
Okay.
nearby sort of focuses that one would read about? Like if I were to go on a Wikipedia like tab explosion, what would be some terms I look up?
Probably uh, cortical circuits, though it might get a little too in the weeds. Um, there's actually a great book by Jeff Hawkins called On
Oh,
Intelligence, and he started his PhD, and I think he left at some point in the 80s or 70s or something. He was just not terribly satisfied, maybe, with the state of uh, data collection or something. And he went off and he made the Palm Pilot and all that
okay,
stuff,
yeah.
made a bunch of money, and then returned to neuroscience in a private capacity. And he wrote this book, which encapsulates several bigger ideas in how this brain works. He's a cortical chauvinist, like several other influential figures. I don't know. He's a little bit on the outskirts. Sometimes academia can be a little snooty or whatever. Who knows if his ideas and his institute is going to shake out and everything, but I think it's great to have theorists.
Totally, yeah.
Have neuroscience is lacking in big theoretical ideas, and more people we have working on those kinds of things that can really be put that we can try to find empirical evidence for. That's great. So that book is something that I might check out. It's got a decent description of this idea of hierarchical organization of the cortex. So we've got, like, say, the primary visual cortex. There's also a primary auditory cortex, which is like the first stage of processing. And what happens there gets sent up to a higher area that deals with higher level features. And then that gets sent up to another area that deals with other higher order features. For instance, a cell in the primary visual cortex has something called a receptive field associated with it, which is like, what is the stimulus that drives activity to this thing? What is this neuron tuned to? In other words, like, what makes this thing resonate? And the primary visual cortex, it would be just like a little area in the visual field that's like a little oriented bar. Say it's a black background with a white bar oriented in a particular way. Now, if you might think it's like dots of light would stimulate things in the primary visual cortex, but no, that's the retina or the LGN, which is the stopping point on the way to the primary visual cortex. But once you get to the primary visual cortex, you're basically looking at these little bars. If you turn the orientation differently, then it's no longer responsive. So the orientation is important. The spatial frequency is important, as in how wide is this bar? Is it black on white or is it white on black? These kinds of things. Now, what can you do in a higher cortical area with all this bar extracted information? Think about it as like pattern matching. It's a little bit like all this autocorrelation thing we're talking about. You just say, how well does this feature match what's happening in this spot of the visual field? Matches really well? Oh, fire. And then so things like that can get synthesized in a higher brain area to form edges, say, of a square or something. And those edges, maybe you have two edges that meet at 90-degree angles. And that in a higher visual area, they can sort of get combined and synthesized to create like a shape. And so if you measure the activity of cells, as you go higher and higher in the cortical hierarchy, they respond to higher and higher organized things. There's this fairly sexy paper, sexy in its like splashiness and fun, I guess, which is that they basically found cells they're way higher up in the cortical hierarchy that just responded to Jennifer Aniston space. So it was called the Jennifer Aniston cell. And so like that's how you imagine like getting higher and higher up in the hierarchy to the point where you're identifying particular faces of individuals. Regardless of context, they can be facing left, facing the right. And that's really a remarkable thing. It's this process of abstraction. Like,
totally.
How is it that I recognize who you are, regardless of what position you're in? Because just some really naive image recognition algorithm will be like having a hard time with that. It doesn't understand that all these different angles could be looking at the same object. So extrapolating what an object is and how it might be manipulated in space in terms of rotation, shading, the light, the context, and things like that. So that's a big part of this cortical processing stuff, is the abstraction as you move up in this hierarchy. And another big part, especially that I'm involved in, is this idea that based on your previous experiences, which could be seconds ago, milliseconds ago, or much longer. You're going to take in your current input and sort of generate what you expect to happen in the near future.
Mm-hmm.
And if things just sort of happen at, like you expect them to, you may not need to pay so much attention to it. It's not perhaps that important. You should just use your mental resources to think about what you're going to say in the podcast later or whatever. There's no predator in the woods. But if you did see a face pop up along the fence where you normally don't see it, then this violation of an expectation gets sort of signaled upwards. So there's the idea is the brain is generating, there's a generative model in which we're always sort of saying, how does what I'm experiencing now compare to what I expected based on previous experiences? If it deviates, then I should probably notify the higher visual areas or other parts of the brain to say something important has happened, and also update my internal model of what I was expecting to happen.
So is this that like the Bayesian brain type stuff, like the free energy stuff? Gotcha.
Yep. Carl Friston is big on all this kind of stuff, and he's the originator of the free energy theories of the brain, as far as I know.
So I talked to this guy a while ago, Andres Gomez and Mielsen, and he's interested in stuff like that, like the free energy principle. And he did this article about like different models of aesthetic qualia, or like different models of art. And one of them was basically to generate predictive coding errors. And I thought that was interesting, like way to think about art. And it made me think of like stand-up comedy, where it's like some of the best comedy is like what makes you have a prediction, and then it like violates that prediction in a way that's novel. I guess
Predictive coding is exactly what I study. It's exactly what my experiments are designed to look at. Both the aspect of how does the brain adapt during the process of while it's acquiring these experiences in such a way that sort of suppresses expectation and also notifies of a violation of the expectation, and hopefully how that internal representation that is doing the template matching is organized. But these are all great, wonderful ideas that are sort of central organizing principles. How to do a whole bunch of just dumb individual cells assemble themselves in such a way that makes this happen, that's really the billion-dollar question. And I'm basically in a position where I love all that theoretical stuff. I'm also trying to figure out anatomically what's going on that enables these things to happen. So ultimately, we won't necessarily. So there's a lot of ways that you can look at predictive coding, and we need to somehow constrain those theories, accept them, reject them, test them based on actual physiological evidence. And that's where my research lies.
Interesting. So when we were talking about like vision and the auditory system, and if there's some unification, I guess I was thinking about like the virtual reality realm, which is going to obviously be more and more like omnipresent going forward. But like if you're in a VR thing and you're in some sort of virtual environment, you can't really experience food, like virtual food, the way that you could like virtual audio or virtual visual input. I'm curious, do you think there's any potential for like just swapping out, like if you were to have a virtual soda in a virtual environment, could you somehow like inject auditory or visual input to sort of trick the brain? I mean, something
I don't
to
think so.
test
But
empirically.
that's a pretty interesting idea. But no, I think that the pathways are just going to be too distinct.
Okay.
Like I don't think you could, man. I think you probably need something more like cap that you put on that'll stimulate brain areas. Like you
Okay.
have with prosthetics. There are people with prosthetic, like robotic arms. Basically, they've got sensors and ways to also stimulate the brain, so
Mm,
like the inverse of a sensor. It takes stuff like that can be done coarsely,
mhm,
but when you're talking about uh, the level of precision required to get something really right,
mhm.
just stimulating through the scalp is too coarse, and we're not really at the point where we are going to be putting electrodes in people's brains
Right.
to give them a virtual soda.
Yeah.
Maybe for you know reestablishing vision or something like that, it's always going to be the most severe deficits and diseases that are going to be
Right. Okay.
highest priority for that kind of research. And
Mhm.
I think we're kind of on the cusp of it, but it's also just difficult to access that many neurons in a highly specific way. Even if we knew how to do it, even if we knew exactly how these sort of circuits were working, it would still be really, really hard to get the
Mm,
technology in there to stimulate with the specificity that you need for things like that.
right. Interesting. Okay. I also think of this guy. I think his name's Neil something or other. I forget his last name, but he's like a famous cyborg, and he has like he's the anglerfish dude. He has like a some sort of antenna that was implanted in his head.
Yeah.
And I think he's colorblind, and he like replaces some sort of sensory input with like the auditory input, and
Uh
it's
huh.
supposed to like I can't imagine that I would like switch it up from like colorblind to like standard vision, but
Sure.
I don't know. It's that sensory blending thing seems intriguing. So yeah, just want to mention
Yeah. I suppose that stuff. It is information
that. Hmm.
that you could use to learn about your environment, and maybe in some really abstract way, it might it might fill in. But um, yeah, is this a TED talk? I think I might have seen this.
Oh, maybe I could see
Yeah.
that.
Yeah. Um, yeah. Yeah. It would be. I'm a little out of my depth in terms of you know it's not really my area
Hmm.
of research, so I can only really speculate. But I would imagine that. So this quality of stuff you're talking about,
Hmm.
it's like, guess I'm saying that you might be able to use your anglerfish thing to
Yeah.
generate some auditory information that could be informative,
Hmm.
but I'm pretty doubtful that it's going to generate the experience of color,
Hmm.
in the same way, in a way that would be recognizable to a regular, um, a healthy normal or whatever. But I
Yeah.
say that with love because I'm also colorblind, but
Oh,
not dichromatic like I think this guy might be.
gotcha.
Yeah.
Um, I guess like a few more things. Jib jim boom boom. So I mean, so it sounds like optogenetics is not your like that's just like something that's happening in the lab as well, or
Yeah, it's a um, it's a project that actually. So this was a cool experience. When I first started reading about the brain, I was interested in music and music cognition, and was reading some papers. And there's this guy who was writing really neat papers about like analyzing speech patterns of different languages in Europe
mm,
and trying to. There's something called prosody, which is how your voice goes up and down in this particular kind of fashion, and I might go like down at the end of a sentence. Like he was trying to sort of relate that to melodic contours
mm-hmm,
in for composers of these different countries. I was like, oh, that's so cool. And he ended up coming to BU a couple of years ago and giving a talk, and he was talking about parrots and beat recognition and bobbing your head to to beats, and humans can do it. We can dance, most of us. And the question was, so this is a sort of predictive problem also.
Mm-hmm.
If you have this kind of pattern, I know when the next one's going to occur because I've got this memory of the clicks or the rhythm that preceded it. So I'm projecting into the future. And that's the part that sort of ties into our lab. So my PI and I, Jeff Kapornik, started talking about this after the talk, and thought, oh, I wonder if these animals like parrots and humans are they the only ones that are really capable of this kind of temporal processing, or are we the only ones that find it intrinsically rewarding?
Okay.
So
interesting.
Our idea was to basically put a mouse in a box. One of the things a mouse does regularly is that it rears up, just looking around. So that's a behavior it is accustomed to doing. And we said, can we make it so that we give it a little dopamine reward when it rears up in concert with a beat, a rhythmic beat? So maybe it's not intrinsically rewarding to be bobbing your head as a mouse to some click, but maybe we can make it rewarding by stimulating the dopaminergic areas of the brain when it does the right things. And we can see, if this mouse never learns, then maybe it just doesn't have the circuitry, or maybe we didn't do the experiments right, or maybe the dynamic, it's a different kind of molecule other than dopamine that are involved in these things. But if it does work, then we have a really cool video of a bunch of mice that are like bobbing their heads to music, and so that's the project. The surgeries involved to make these things happen are pretty time consuming, and I don't particularly love doing that. So we basically I've sort of walked away from the day-to-day of that, and other people will run the experiments and do the surgeries and things. I sort of keep my eye on it from afar. But yeah, the project is called Tiny Dancer, and maybe it'll pan out.
I'm imagining a little like Night at the Roxbury scene of
absolutely, that'd be the best. I guess one note on animal use though is though this stuff sounds uncomfortable or mean or something like that, you'd be amazed at how unperturbed these mice are after these surgeries. It's like they just have a new hat. Like they wake up and interview, like nothing has changed. They're fine. So I'm just gonna throw that out there for
the vegan you're talking to. But I mean, I am vegan, but I'm not actually bothered by what you're saying. What was I going to say?
Well, it bothered me, the idea of working with animals and everything, and I don't want to inflict harm and suffering on other living animals. But once I saw how kind of robust and uncaring they are about these kinds of manipulations, I felt better about being involved with it.
I'm curious if you're interested in sonification of data at all, if that's like something that seems worthwhile. I feel like other people have been sort of bullish on it and other people are disinterested.
Man, I haven't thought about that in a really long time. So it's something that I was thinking about more when I was an undergrad and doing research on synchronizing networks, and just tired of looking at all these plots of like hundreds and hundreds of cells and trying to find out patterns. And I thought, oh man, maybe I can just make a little plink, plink every time the cell fires or something, and try to maybe put them all in a stereo image so you can get some idea. But it's not something that I think is. I'll have to mull over whether or not I could use that in my particular area of research. I'm mostly trying to do statistical tests and model fitting and things like that. And I'm not really sure if I could make use of sonification in my particular domain.
Part of me feels like if you're like, trading stocks or something and you were to speed up the waveform and put some pitches on it, if then you could, be more predictive if you did it in a musical way. But that's out
Maybe.
there.
Yeah, maybe. So one funny feature of a lot of cells in the visual cortex, especially in the layer that I'm looking at, is that, I said there's these receptive fields that you could put up on a screen, some image that might cause a cell to fire, but individual cells, especially the further you go up, don't necessarily encode for some stimulus or feature that robustly.
Mm.
So it might only fire, you might say, yeah, this neuron is selective for this kind of thing, but it might only fire 10% of the time that thing is there, and maybe like 1% when other stuff is there.
Mm.
So there's the sparseness. And so the idea is that in whole sort of populations of cells, in aggregate, they'll reliably encode for some kind of thing, but each individual one doesn't necessarily.
Gotcha.
That's kind of an interesting, still kind of an open question as to how all that works. But if we're trying to sonify waveforms of individual neurons or something like that,
Mm-hmm.
it might be too sparse for you to extract
Gotcha.
meaningful information, and you really need to do some more population level statistics or something.
Interesting. Okay. I guess the last thing I'll ask is like about research and experimentation. I feel like I've never fully appreciated how to go about research and do science, as it should be done. So I'm curious, how would one design a solid research question, and sort of do you see any interesting areas of low hanging fruit for like artistic or musical research?
So I gave this some thought because you put this in the email, and I was thinking, boy, that's a tough one. Um, because I feel like for what I do, there's a lot of reading just to determine what gaps need to be filled.
Mm-hmm.
What has everybody done? What can I, with the tools that I have, do to fill in one of those gaps? Now, on an individual basis, it'd be pretty tough. It's tough for me to think of something that would be novel, that would contribute to the field as a whole. However, I was thinking about these psychophysics experiments from the 50s, and for example, tone discrimination. How you play two tones, did it rise, did it fall, is it the same tone? How far apart do two tones have to be for you to be able to discriminate between the two? If there's some white noise in the background, how does that affect your ability to discriminate? If you increase the white noise, it decreases discriminability, and all these sorts of factors that were really mapped out a long time ago. There's also memory related things like this. You could say if you get a list of words, for example, 10 of them, and you're asked to recall which words you heard,
Mm-hmm.
you'll tend to remember the first couple pretty well and the last couple pretty well. So there's like this recency effect, but also at the beginning. So there's all these kind of easy to do psychological experiments or psychophysical. And I always thought it'd be really cool just to do those on myself, like map out my own curves,
Mm-hmm.
which I think anybody could do, really. You just
Totally.
have to be really careful with your equipment. Make sure that you're using the same settings on your headphones when you do these things.
Mm-hmm.
And so I guess my answer is I'm not sure what low-hanging fruit would be in terms of contributing to the overall pantheon of scientific research or psychological research. But I do think anybody could have fun just
Right.
finding their own individual characteristics of their hearing or vision or whatever. I think that actually I've wanted to do that for a long time, and I just never have. And also
There's a
mapping it over
turn.
time, like just how your frequency rolls off as you age, or
Mm-hmm.
or oh, here's one. try to uh, map out, like we were just doing this click thing, map out how close you are to, how able you are to approximate the next beat as a function of how far the beats are from one another.
Okay.
So as the tempo slows down, as you know, like playing in a really slow tempo, boom, boom,
Right.
boom, it can be tricky, right? And we
Totally.
learn techniques like subdividing, which is kind of like a way to sort of cheat and to make a slow tempo into a faster one.
Mhm.
But try to do something like that for yourself and uh, see if you can get better at it. See if you can modify the tempo itself and see how quickly you adapt and create your own learning curves. Make it a non-standard or a non-steady tempo, and things like that. So like how well do you track it? Those could be kind of interesting exploratory questions.
Yeah, I suppose you could even like sort of quantify how accurate your sense of rhythm is or something like that. Or, like that's not really research per se, but it's like, self-inquiry, I guess.
Yeah, yeah.
Do you have any sort of like guiding principles for coming up with research questions in general?
Uh, Good question. I wish I had a um, more, I don't know, rigorous way or process, or something like an algorithm. I would recommend a podcast. You can edit this out if you don't want the competition, but a podcast called Rationally Speaking.
Julia Galiff?
Yep. And there's an episode with Ed Boyden, who's
Okay.
co-inventor of optogenetics, along with other things. And she asked him something kind of like this. And he had much more of an interesting methodical way to think about how you might approach things, and how he was able to come up with the ideas that he had. And he's a brilliant guy, and he has a better way of putting these things than I do. Mostly, I just sort of bang my head against the wall for a while, and then try to step back and think about bigger context, and hope something shakes out. There's so many confounds in designing like a good experiment that they all individually seem like they're their own beast
Hmm.
sometimes. So it's hard to come up with general principles.
For sure.
But yeah, that's probably about as much as I can say on that.
Well, when I come up with a research question, I'll send it your way and you can
Please do. Yeah, hit me
criticize
up.
it. Cool.
Hey, well, I'll try to punch it up, and we'll like throw it back and forth and see if we can come up with something. I love to hear what people come up with and ideas.
Yeah, I mean, I should also send you some of the like algorithmic stuff I'm trying to sort out for my music stuff because I'm trying to do this like algorithmic death metal project, and
Uh-huh.
I'm just really dedicated right now to figuring out how to slice up a 30-minute span of time into some sort of way that I can like feel good about and then automate it so I can just
Huh.
continually generate like structure and form for like one side of a cassette.
Right.
So
Well, I think one kind of fun thing is to, like, we were talking about expectation and surprise, and you can quantify surprise.
hmm,
They're, including Carl Friston, who I mentioned before, have formulations for quantifying surprise based on previous experience. It could be kind of cool to try to apply that to your own compositions. Say, oh, there's been a lot of regularity for some period of time here. Like this could be a good spot for something,
mhm.
you know, in terms of algorithmic generation.
Interesting. Cool. Well, I'll have to read about I mean, what is the way that you qualify or quantify surprise?
How?
Yeah, or is there a term for it or like some sort of process?
I can send you some papers. There's several, but one of them that I'm still just kind of working out right now because it's part of my research is comes from a more information theoretic approach, which is like, if you receive some data and it doesn't change your model, your internal model of how things are, then it's not really informative.
Okay.
And so you could say, what is the least informative? Like, if we're just doing clap, 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 the least informative thing would be the thing that is exactly what you predict to happen next. So I think that's the intuition, is, does this piece of information change my internal model of what's happening? Or does it deviate from my expectation? And if you can figure out a way to, I don't know, apply that idea in terms of composition, that could be pretty interesting.
Cool. Well, I look forward to reading whatever you send me. Anything you want to say before we close this out?
Let's see.
I mean, there's information on Gavornik Labs website, right? I think I saw that interval paper, and I read the abstract about the prediction and stuff.
Yep. Shoot. I don't know if I have any closing remarks here. Just want to give a shout out to my homies, and
any like records you want to sell or anything?
Nah.
My huge audience.
Nah, I don't want to sell anything except for maybe fretboards. Go to MicroTone Guitars, drop us a line, buy yourself a MicroTone guitar.
Who did that logo, by the way?
Mike and I worked on the logo together. We had the idea of basically using sine waves, having harmonic, like perfect harmonic ratios. I think it might be a 5/4 one for the perfect third. I can't remember exactly what we did. We basically just kind of tossed. I used my plotting software, my Python and all that sort of stuff, to sketch some things out, and I would send it to him in EPS format so he could put it in Illustrator and make it pretty. But it was basically some fusion of
awesome.
Yeah.
I feel like it
working on that stuff.
Looks very much like the sort of like manic scribbles in some of my notebooks. So where I'm just like splitting it into 3. Anyway.
Yeah, cool. Yeah. I was trying to go for something not too busy, but got the idea across.
Cool. All right. Well, Scott, thanks for joining me. I'll talk to you later.
Yeah, it's been a pleasure. Thank you for having me.
Adios.
Ciao.